Testing, testing. Testing, testing. 1, 2, 3. How about now? Okay, that seems reasonable. All right. And all right, let's begin. So I don't have a lot of time tonight, so we're gonna probably do something a little different. So I've been having computer troubles all afternoon. My USB devices keep disconnecting. Found out that this is a glitch with my motherboard and CPU, and there's really nothing that can be done about it until mid-April. So we're just gonna deal with it. But I probably won't be streaming that long. So what this is a speaker design that I've been working on. So I just want to push it to the point where I can print out a prototype. So we got 2 tweeters up here, subwoofer and enclosure for the sort of driver down here. So it's almost there. What we need is to make it printable. So right now, just open the master. Yeah, so right now we've got the tweeter split up into 2 bodies. Let's show those. Yeah, 2 bodies here. And got your parting line here. But I really want to have a way to take this apart after I put it together, especially on the prototype. So what we're going to do is we're going to add some holes for threaded fasteners coming in from the back. So here's the first one that I printed out. Took about 9 hours to print, and realized that there wasn't any way other than glue to just put this together. So we're gonna fix that now. So we're gonna roll back in the feature tree to probably just after we create the tweeter mounting. Yeah. Yeah, see there, like my mouse just stops moving for like no good reason, just because the mouse disconnects. It makes it really hard to do like anything on a computer. Oh, actually, yeah, so we're gonna have to go back to here. Should be pretty straightforward. So we're just gonna come, I think I made a plane for this. So we're just going to create an advanced hole on this surface. I think we're going to make it countersunk, clearance hole, then a straight tap. Make it a M3 socket head cap screw. And we're going to have it affect both of these. Okay, it is going the wrong direction right now. Let's try this again. We're gonna come in here. Probably just gonna offset this. That might fix what we're dealing with. Flip the normals. Yeah, this should do it. Only want it to affect those two bodies. Now we just step through making sure it clears everything. Yeah, okay, so why you gotta be like this? Well, maybe if we place it, it will be a little more intelligent. Probably something like that. We'll fill that in later. I think overwriting this is going to be what we want. Yeah? No. Oh. Right. And we send it to that surface, and then this last thing is just blind. We're going to do 2x diameter, flat bottom, because it's a 3D printed part, so who cares? And there we go. Now this is suboptimal because it has created this hole in the middle of the part, and oh man, it's hard to get a good view of that. But you can see that the countersink doesn't actually pierce the surface, so we can fix that though by moving this plane up until it does. Ta-da! Now it pierces. So yeah, you can see it easier here. Yeah. So now we just have to make sure that that hole is placed somewhat intelligently, which it is certainly not right now. Just gonna hide that. I know I made a sketch here. That. Oh, does something with this. Maybe this one? Nope. This one? Oh. I'll be right back. Hello? Hello, hello? Hello? Fucking God. Hello, hello. What's up? Hello? Oh my God. Hello? Yeah, what's up? Did you get the email that I sent earlier? Ah. Um Oh yeah. So if can you open your mail on your laptop? Hello? Oh, you know what? I'll just log on and help. Hang on. Um All right, so just click OK to let me help out. Great. Okay. So let's go over how to do it from here. Oh, here we go again. Alright, hang on. Alright, let's try again. Oh shoot, I forgot. That should work. There we go. All right, I'll get back to it. All right, bye. All right, and we are back. What we were doing is trying to find like a midline here. That may not actually be something that I've created, so maybe we'll just do that again. So what we'll end up doing is creating some offsets. Yep, and just create a circle. So turn these into construction geometry, and this isn't pretty, but it's the easiest way I've found to sort of make a quick and dirty midpoint here. So then we're gonna pop this guy. Geez. Oh, okay. See, that's why we won't be streaming very long today, is because it keeps glitching out on me like that, and it's super hard to get anything done. Just sort of destroys me. So then we're gonna do a circular pattern. Or actually, no. Scratch that. If we can do a segment here. Yeah, there we go. So we're going to create a sketch segment, and we're locked in. So that should be a little cleaner. Oh, it's saying we're not fully defined. Why are we not fully defined here? Now we are. All right. So now we should have these. What? Oh, oops. There we go. We got these two bodies here, and we have a clearance for the socket head cap screw here, and clearance for the bolt, and a threaded hole. Let's see how we're looking on wall thicknesses here. Probably fine. I might even make that a little bit deeper. Those threads never really seem to work out quite right. Just come in here, pick the threaded part. Custom, send it down 10 millimeters. Oh, other fun thing we could do is we can put actual thread geometry in here. Yada yada yada. So by default, the thread feature does not actually create thread geometry. So what you got to do is you got to go in and model that at least semi-manually. Let's see. So yeah. That should do it. Ah, except it. You can see here it starts just below the surface. So what we gotta do, start that a little bit up. I know there's, yeah, there it is. Zoop. Okay, so we can start a thread up, actually 2 threads up. And now we get that nice smooth lead in. Actually, what we might do is we might roll back and we might actually chamfer this. Whoa, maybe not that much. Add a nice little lead in chamfer for our threads, as long as we're at it. That will break our feature, but that's fine. What that's done is it's destroyed our reference because we chamfered that edge away, but that's fine because we can just select a new one. It won't let us select the big one. I guess that's fine. I am really suffering with this keyboard lag here. It's kind of destroying my my workflow. I really like keyboard shortcuts, so when you hit one and it doesn't actually do anything, it really throws me for a loop. So please bear with me here. Now there's gotta be gotta be a way to do this. Yes. Okay, so what we're going to do is we're going to pattern this based on the sketch we used to create the hole. Ha ha. Ha ha, that's clever. I'm proud of that one. Neat. So that means those holes will be threaded. That should be fine. Now we gotta build in some more threads here. So we're gonna roll back this one and do the same thing here. Same exact thing. That'll just be a little more difficult because it's not really set up to do that. So here's our equivalent feature. So we're going to go in, create another thread feature. Almost forgot the chamfer. Now the thread. Come on. Why doesn't it like this? Smarter than I'm giving it credit for. Doesn't usually happen, but it's just being ornery. It's an M4 by 0.7. It's a metric M4 by 0.7. I legitimately can't tell if this is a graphics glitch on my system, a problem with USB just randomly disconnecting, or SolidWorks being crazy. That is a really, really annoying position to be in. See if the internet has anything to say about this. I suspect this is some sort of graphics glitch. I am not 100% sure how to fix it, but we're going to try rolling to end and applying the thread on the last part here. This may or may not change anything. It changes it. Probably has something to do with section view, but like I don't know. Right, so it's M4. Not getting any preview here. It's a little concerning, but there it is. Cool. So flip offset, and we're business. Now, the question is, can I reorder this so I don't confuse myself in the future? Yes, I can. Maybe. There it is. Alright, now we can do that same cute little trick where we sketch-driven pattern. That is actually not correct. Okay. And there it is. Neat. So that has increased the face count on this part by an absolutely obscene amount, but that's fine because I'm running this on a usually incredibly overpowered machine. So I only suffer a little bit. Except when the USB devices, like my mouse and keyboard, disconnect randomly. Let's see, what else we got? Oh, I didn't realize that. We're gonna have to fix this. This is probably not okay. Fortunately, that's, I think, relatively easy to fix. Yeah, and that still stays bound. So we're just going to create some construction geometry here. Yep. And dimension that. How does that look? What? There's a point here. Absolutely is not. So it must count intersections as some sort of point feature. It's pretty weird. That's fine. Let's do a quick sanity check. Nothing seems to be puncturing, so that's fine. There. Now, what we're going to do is we're going to do a little bit of 3D printing. So I've got this add-in here that exports stuff directly to Cura. So that's a slicer. So what we're going to do is export all that. There's our part, but oh, this is not the way to do this. So this is the master. We really shouldn't be exporting directly from the master. So we're going to come back here, and this should rebuild and save. So all our new features should get pulled in. Yep. There it is. So we're going to grab this child part. Yep, there we go. So now when we export this, it should come in as one body. There it is. Okay, so the features that we really care most about are sort of this face here. Well, is that true? Let's see what the supports tell us. Oh, okay, yeah, that's silly. That whole support structure just to build that little tiny overhang. So we're gonna alter the support material here a little bit. Actually, you know what? We're just gonna turn off support and reslice. Yeah, there it is. And this is a super small kind of thing, so we're gonna probably turn off build plate adhesion. Yeah, that's pretty good. 8 hours, 34 minutes. We're at 20% infill. Drop that to 15. This is purely prototyping. What we are going to do is cubic what I want? Let me check that again. I'm going to 3D infill. Oh, I remember. Okay. So let's, yeah, cubic's probably fine. We'll stick with cubic. Reslice. Brings us down to 7 hours, 49 minutes, and 57 grams. So yeah, I'm just gonna go grab the stick and we'll get this printing momentarily. Alright, so we got that plugged in. Save to the removable drive, eject. I'm just gonna go plug this into the printer. I'll get a camera over on that thing eventually, and then we can have it on stream. Alright, so that's about done. So while the printer is coming up to temperature, let's do just a little quick demo of how this 3D printer works. So this is an FDM printer, and what that means is it has this spool of filament, and it melts it and squeezes it out like a hot glue gun, and it lays it down in these tiny little layers, and by laying down layer after layer after layer, it can build up 3D objects. So here's the first layer it's going to lay down. It's going to lay down this little sort of test area here, and then it's going to start off, it's going to go and lay it down sort of in this pattern, building up the first the first layer of the print. And then it'll move on to the second, third, and fourth, and each progressive layer it's going to lay that material down. Now for the layers in the sort of like in the middle that don't really need to be there to give the shape, what it's going to do is create these, they call it an infill pattern, where it sort of builds a mesh inside the part. And what that does is it really increases the speed of your print, and and decreases the amount of material that you need. So you can see it building that up, and here's our thread feature. So that's gonna have, oh wow, I'm not used to manipulating this. It's gonna have a lot more sort of density in that area, and it'll just keep doing that over and over and over and over again until we get all the way to the top, and then we're done. So the question here, the sort of the trade-off here is you get pretty good resolution sort of in the XY plane here, and the Z also has pretty good resolution, but you do get sort of like ridges, right? Which is what gives you that classic 3D printing texture. I don't know if you can see this, but it has sort of it circles like this, but then if you do this, it's got a texture there. It's not so bad, but it also is weaker in that direction. Like if you were to tear it apart this way, it would be much easier to tear it to separate those layers than it would be to split it the other direction. So as you're designing your part and as you're orienting it for the print, you have to think about what orientation is going to get you the most resolution in the direction you care about, and what's going to give you the most strength. In this case, strength isn't super important, but having those threads come out in high resolution is gonna either mean that I can just thread the screw right in there and everything just sort of works, or I have to go in and clean it up with a tap. Either way, pretty easy though, so not a big deal. But let's go back to the master here and unhide everything. Now, that's about all I want to do on this guy for tonight, so we'll do one last little side tidbit here. This is called GrabCAD, or more specifically GrabCAD Workbench, and this is a version control and collaboration platform for CAD. There are a lot of different things that you can do for like software type stuff, but CAD uses binary files, which don't play nice with text version control, so you have to use something that just deals with binary instead of text files. It really limits your options for things that manage that intelligently, but this is a pretty good platform. So what you can do is it finds all the files in a folder on your computer, and in this case we have the spherical based speaker folder, and so we can tag all the new versions, all the new files, like all the new versions of those files with some sort of comment. So I'm going to make a note here, something like added threaded fasteners to the tweeter, and added, interesting, added what is the SolidWorks name for that? I'll just call manual threads on the holes for 3D. There, and then when I look back at this, I can see, hey, that's what I did at this version, and if I need to roll back and undo a change, I can, which version I want to go back to. You just upload it, just like that, and now everything's up to date. Kind of hoping I'd be able to demonstrate how you can open this. Oh yeah, let me just log in here. is. Okay, so here you can see all the project updates that have been pushed recently, especially on this, specifically on this project, and you can even view changes. If it has a minute, let's check a different project that's had little. No, that's still thinking. Let's view a different project. Oh, nope, there it is. Okay, cool. Yeah, you can directly connect to Stratasys and all that jazz if you really want to. Yeah, so you can view everything here. I know there's a way. Oh. There we go. Alright, yeah, and you can explode stuff. Which is a neat little feature. That's not really what I was looking for. Just trying to view. But you can see just about everything in there. Great little feature. Great way to share CAD stuff. But anyway, this constant USB disconnect issue is kind of bugging me, so I'm gonna log off and try to fix that. I'll hopefully have that fixed by next time. So anyway, see y'all later.